Parkin.
Derek Moore.
I'm Kyler Fillero.
And I'll go ahead and introduce our project for our embedded systems class. What we decided to do is implement an auto turret gun where we implemented using IR sensors, a servo motor, and a turret gun. And what the project does is it follows the individual when it's within range. As they move back and forth, the turret will follow the individual, and then when they reach a certain threshold, the turret gun will fire. And so you can see here, here's our project. And the turret gun is what I was in charge of doing. I wrote the Verilog code. Basically, it just implements a register file, and in our software, when you write to the register a 1 through the memory location across the APP3 bus that we implemented, it will fire the turret gun, and then when you write a 0 to that memory location, it will turn it off.
So the servo in and of itself is just basic pulse width modulation. You have a counter, and partway through that counter you turn a value from high to low. And the servo is actually based on the length of that high value. Depends on which area it goes to. So with our project, we have 7 different sectors representing various combinations of these IR sensors, the 4 we have. And based on which ones are picking up, will based on which sector the servo gets turned to through that counter.
So I took care of the analog to digital converters on the board. We use the SmartFusion's built-in A to Ds. And so the IR sensors give out an analog voltage, and we change that voltage. It's converted to a digital value, read in, and then what we do is we set a flag based on a certain threshold. So when you're out here, based on each sensor, we'll set its own flag, and that's how Derek's part for the servo will know where you're at. So when you're here, it'll set a sensor, or set a flag for this sensor. When you're here, it'll set one for this one, and so on. When you're within a certain range, so when you get close enough, a different flag is set, and that flag is what actually stores the value to the register that controls the gun.
The hardware that we had to implement was on the turret gun. The board provides 3.3 volts, and that's not enough to drive the turret gun to fire it. And so what we did is the board also supplies 5 volts, but that's separate from the code. And so we wired the 5 volts over to here, and what happens is when the gun needs to fire, it sends a 3.3 volt signal, and here on 2 BJTs it biases the gate voltage on one of the BJTs, where it will allow the BJT to turn on, acting as a digital switch, and then it causes that 5 volt supply to create the current, which then drives the load to the turret gun. So we had to implement that additionally, as mentioned, because the 3.3 volts was not enough to drive the turret gun.
Okay, so we can see as we move across the sensor array, the servo adjusts to each sector, and the gun tracks your movement as you move across the sensors. So we can see that. So next we're going to demonstrate the actual firing mechanism. So the threshold for sensing your movement is somewhere around a foot away, as we can see here. And when we move in, once we plug it in, when we move in closer, it'll automatically fire once you're within a certain threshold.
Now, so as I step in within that threshold, it will pick up my distance, and then I'm going to go ahead and move, and you can see that it's tracking my movement. And then when I step in to the certain threshold, it will fire. And that's our working project.